Hello engineers, welcome back. In the previous video, we saw the concept of merge sort. In this video, we're going to try and code it in C++. Okay, I hope you're ready. Let's get started. So just a quick recap of merge sort concept. So given an array, we initially divide the array into smaller arrays. We break the array into two pieces and then break it down further until we reach the end where there is no further breakdown is possible. And after that, we start to merge the arrays from the bottom up until we reach a point where every sub-array is sorted and the final sorted array is reached. Okay, for this, we're going to use the concept of recursion to break it down into deeper levels. And then when we do the merge, we're going to take help of two temporary arrays, and then we will iterate over them to fill the main array with the sorted values. Okay, so let's go to our VS Code and let's get started. So I've created a new file called merge sort. I have created the base template. We can quickly get started. So let's create a vector of int v. Let's push some elements into it. 13, let's say 11, 12, maybe 7, 5 and 6, something like this. And we're going to make use of a couple of functions. Let's create a function to print the vector first so that we can use it for printing the vector before and after the sort. So this is the function print vector. It takes in one argument, which is a vector of int, and we're going to pass it by reference instead of passing it by value. Okay, so inside this we'll simply print it int I equal to 0 while I less than v dot size. I will keep moving forward, and while it moves forward we'll simply do cout v of I. Let's give some space, and that's it. So this we can use for printing. So let's call it print vector v. We are passing the vector, and we can say cout before sorting, and we can do end line here. Let's run and see if our print function is working. Yeah, so the print function is working fine. So now let's create a merge sort function. So it will not return anything. We will change the main vector in its place. So let's call it merge sort, and this will also take one vector and it will take it by reference. So we simply pass the vector to this merge sort. So whatever this function does, the implementation details are hidden away by this function using the concept of abstraction. So only the vector is given to us, and when it returns, we will simply do cout after sorting, and the expected output is that the given vector is sorted. Okay, so let's see how we can build this. First of all, we are going to need a function which will break down the given vector into its sizes, right? So for that, we will create two variables. First is we will create a left variable which is 0, and we have a right variable which is at the end. So this is v dot size -1. So this is the left and this is the right. So these are the ends of the vector. Now we will create a new function called sort, and this will take a vector by reference. This will also take the left value. This will also take the right value. It will take both the ends, and we will use this to break down the main vector. So how do we do this? We simply pass our vector to this function, and this function will do the remaining things. So what will it do? So we will use the concept of recursion to break down the vector. So first we need to find the midpoint. So we can say mid is right minus left divided by 2. This will give us the midpoint. And we will call the main function, sorry, the sort function. And this time we will not pass both the ends, left and right. We will pass left plus mid. And that function will call itself, and it will further break down by calculating a new mid, and that function further calls another function which will break it down to another mid. Okay, so let's see. So we're going to pass the same vector again, and this time we're going to pass left to mid. So this will call the function itself, and it will keep breaking the vector by half on the left side. Okay, and as you can see, sort is calling sort. So this concept is called recursion. A function calling itself is called recursion. So we will see it in great detail in the future videos. But for now, you understand that when we do this, it creates an infinite loop. So sort is calling itself, and this goes on forever, and our program will never end. So we need a break condition. So what is the break condition? Break condition is if left less than right. What do we mean by this? I'm saying only if left greater less than right, you do all this. Okay, otherwise you don't need to do anything. So what do we mean by this? So the right value is changing with every call, right? So we are passing the same vector and same left value every time, but we are changing the right value. So initially the right value came from here, which is the entire vector size. But for every inner call, we are changing the right value to the new mid. So when the first call is made, we calculate a new mid between left and right, and then we pass in the mid. But for the second call, we calculate the mid between left and mid, and that creates a new mid, and that calls the new function. Okay, and this continues until mid at some point will become equal to left. Okay, if we keep on dividing it, there will come a point where mid will become equal to left. So at that point, we don't need to break it down any further. So that's where we will stop. Okay, now this is the left side of the chain. So we are breaking the vector on the left side. We can do the similar thing for the right side. How do we do it? For the right side, we pass in mid plus 1 and all the way up to right. This is the second half of the vector. This is the first half. This is the second half. Same concept. And once we do all this, we will merge them. Okay, so we will create a new function called merge. This will take in obviously a vector by reference. It will take in the left value, it will take in the right value, and it will take in the mid value as well. So let's call it here just for readability. Left, mid, and right. Okay, so this is where we do the merge operation. So this divide piece is taken care by the sort function, and once we have the divisions, so once we have broken it down to a level where nothing is left, we will start the merge. So we will merge the left with the right. So this will break down this main array into this piece, and this breaks down further, this breaks down further. Now we reached here where no breakdown is possible, so we will start to merge these two. Okay, so that's why we pass in both left and right and mid. Okay, next let's pass in our values. So we have left, mid, and right, and that's it. So the remaining logic will take place here. One thing to note here, when we are calculating this mid value, this works well when the left value is 0. For example, let's take an example. So this is our array 5, 6, 7, 11, 12, 13. And when we want to calculate the mid, what do? 0, 1, 2, 3, 4, 5. So we said mid is right minus left by 2. So what is the value here? Right is 5, left is 0 by 2. That will give us 2.5, which will become 2 because this is an integer. Now, this works well for dividing the vector on the left side because always the left index is 0, right? But when we come to the right side of the vector, the left value is no longer 0. The left value is 3 here, 3 to 5, right? So when we do this, 5 minus 3 by 2, this is 2 by 2, that will become 1. And the new mid will become 1. 1 is here. But I want to break the vector on this side. I want to have the new mid here, right? So that's why to accommodate breaking down of the vector on both left side and right side, we simply add the left offset here. So by adding the left offset, we can make sure that this is possible. So let's see how that looks like. So now to break down this vector. So now we have right as 5, left as 3 by 2. But now I will add an offset. Offset is left. So this is 3. So now we get 3 plus 1, which is 4. And that's what we need. So that's why we use a left offset while calculating the mid. So this will accommodate breaking down the vector on both left side and on the right side. Okay. So that is breaking down. Now we will think about our merge logic. So what did we say? We said for merging, we will take help of two vectors, temp left and temp right. So let's see how they look like. To calculate the size of the left vector, so let's say temp left size, we say we need the value between mid and left. So mid minus left. But since this is a 0 vector, we can add 1. So this will give us the size of the left vector. And we need the size of the right vector. Right vector can be temp right size, and that can be right minus mid. I hope that's right. Let's take an example. When we are here, let's say we are here, we are trying to merge these two, and our left value is 0, our right value is 5, and our mid value is, what is our mid? 5 minus 0 plus 5 minus 0 by 2, that is 2. So mid value is 2. So my left vector will be of size 2. But we have 3 elements here, so we will use plus 1. So we will get temp left size becomes 3, and temp right size will become, what did we say? We said right minus mid, 5 minus 2, and that is 3. Okay, so we have 3 and 3. So our sizes are okay. Next, we will build our left vector. So we will start a new vector. Let's call it temp left. And let's fill it. How do we fill it? Int I equal to 0 while I less than temp left size. We can say temp left dot pushback v of I and I plus plus. Okay, so that is our left vector. We can do the same thing for our right vector. Now I will become 0 again, and now we need to create a right vector first. Temp right, and this will be temp right size, and this will be temp right. So we have filled our vectors on the left and right side. Now what do we need? We need to iterate over each vector, and then we will start to change the main vector, right? So let's see how we can do that. So let's take some new variables. Int m equal to 0, n equal to 0, k equal to 0. And what we'll do is we will simply iterate over both the temporary vectors. So we will say while m less than temp left size and n less than temp right size, as long as any one array is not traversed completely, we will continue this loop. Okay, and we will do the check here. If temp left of m is less than temp right of n, we found the lower element, so we will simply push this. So v of k will start with k. K need not start with 0. K can start at left. So whatever is the leftmost index will be here. So this is this piece. We are putting an index somewhere on the main vector, and that will be the leftmost element of the temp left, right? So we have left here. So v of k will become temp left of m, and we can do m plus plus because we have used this value, and we can repeat the same thing for the other side. We will fill the right value now, and we will do n plus plus, and because we have used the index of the main vector, we will push it forward. Okay, so that is that. So let's recap what we have done here. So we are iterating over the left vector and the right vector, and at every step we are checking temp left of 0 less than temp right of 0, first element of two vectors. If the left element is smaller, we will push that to the main vector, and we will increment the index on the left vector. If we are finding the right element to be the smaller one, we will push that element into the vector, and we will increment the right pointer. And because we have used some element, we will increment the main vector as well. Okay, so this takes care of this piece, iterating over the vectors and filling the values of the main vector until one of the vector is traversed. Okay, now we will take care of the remaining piece if there are any elements remaining in either of the vector. So for that we will say while m less than temp left size, which means there is something remaining on the left vector in case. So we will simply do v of k equal to temp left of m, and we will do m plus plus and k plus plus. This will fill whatever is remaining on the left vector. And the last piece, while n is less than temp right size, this will become temp right and n plus plus. So this will fill out whatever is remaining on the right vector. Okay, I think that is it. I hope we have done everything right. Let's run and see. Redefinition of temp left. We have made some mistake. Temp left. Ah, here. We don't need this. There are some errors. Let's see. Requires 3 arguments, but 1 was provided. Where did we do this mistake? Sort. Sort v. Somewhere we used sort v. Here, while calling the main sort function, we need to pass in left and right. We forgot to do that. No problem. We will do it right now. Let's run it. Undeclared identifier k. So this is comma, not semicolon. If you want to declare multiple integer values, we can do like this. So I think this is going into an infinite loop. Let's stop it and reanalyze. So I found a couple of bugs in our code. So I fixed them. Now our sorting is working fine. So let me go through them so that you don't make the same mistake. So first is while we were filling the temp left vector, I was pushing v of I, but we had to push v of left plus I because we are pushing whatever is in the current left index of the vector. And while we are pushing the temp right vector, while we are building the temp right vector, we need to use mid plus 1 plus I. So that is one mistake. And the second mistake was when we were doing the comparison between the two vectors. So I did temp left of m less than temp right of n, and the second if was checking if it is greater. So there were two conditions. I missed the condition of greater, less than or equal to. So that was causing an issue. And another thing was if we are doing two ifs, it is causing the value temp left of m to be checked after m plus plus is done. So because they are ifs one followed by the other, the m plus plus was happening beforehand, and this was causing an out of bounds exception. So instead what we will do is we will simply use an else case so that only one of them gets checked. Okay, so that's it. So I think the rest of the logic is fine. If we run it, our code should work fine, and it is working fine. So just a couple of coding mistakes to look for. So it took me some time for debugging, sorry about that, but I'll share the code with you so that you can practice along. Okay, so that is how merge sort works. Okay, so just a quick recap of what we did. So we created a sort function which takes in our vector with the left and right values. We used recursion to break it down from the left, and we used recursion to break it down from the right, and then we used the merge function to merge whatever was there in the left subarray with the right subarray. Okay, and within merge we took the help of two vectors, temp left and temp right. We filled these two vectors with our left and right subarrays, and we started comparing each element from the left array to the right array, and whatever is smaller we pushed it to our main vector, and that's it. And these two loops are for filling out the remaining values, whatever is remaining in the left vector and right vector. Okay, so that's it. So you can practice along with this dry run. So that is it for merge sort, guys. Thank you so much for watching. If you have any questions, you can definitely ask me. I will see you in the next one. Meanwhile, please don't forget to like the video and subscribe to the channel, and please bookmark the playlist so that you don't miss out on the next videos. And do comment if you have any suggestions or questions. I will see you in the next one. Thank you. Cheers.